Hey everyone, this is Christian. Welcome to AC55 IoT at Home with Minew and Azure IoT. In this third tutorial, I'll show you how to tweak the setup of our. Let's just repeat what the whole thing looks like. On premise, we have a number of S1 sensors and a G1 gateway. In Azure, we have first an IoT hub where we ingest the data, then process it through a stream analytics job and export it into PowerBI and blob storage. And throughout this setup, there are lots of knobs and settings that we can tweak to get better performance, more consistent performance, or optimize for cost. So let me show you some of the things that we can actually do. In this tutorial, we'll go through 4 sections. The first one is tweaking around the S1 sensor and the G1 gateway. In the second section, we'll add reference data to our stream analytics queries to make sure that we can actually distinguish what type of sensor we're looking at and give it a name that is a bit more insightful than its MAC address. In the third section, I'll show you a few more interesting Power BI visualizations and hopefully build on the stuff that we do in section A around counting the number of signals coming off the sensor. In section D, I'll show you how to set up a few visualizations that can help you monitor the data quality off of our sensors. So it's a very rich program. I think it will be interesting for you to watch. Although I acknowledge that upfront as I planned for this third tutorial, topic seems a bit disjointed at first, but trust me, once we've gone through the whole thing, it'll come nicely together. It might be helpful just to remind ourselves what our use case and the constraints are. The use case is very basic. I have 5 sensors at home. I have one in my bedroom, one in my bathroom, one in the living room, one in the fridge, and one outdoor. Right now, they don't necessarily create a bunch of value. I set them in the bathroom and in the fridge mainly to get differentiated data. It's not very helpful to have all the sensors in the same room feeding the same data. So that's why they're distributed in very different locations. The need I have is to monitor temperatures and humidity throughout the house. Particularly, I'm interested in monitoring humidity after showers to see how quickly the bathroom dries out. The second thing I want to monitor is the homogeneity of the temperature inside the house. So that would be in the bedroom, the bathroom, and the living room to see if my AC settings are appropriately set to get a homogeneous experience. Some of the constraints that I have is I don't really need real-time monitoring, as in down to the millisecond. If I get data every 30 seconds, that is just fine. That is technically near real-time, but we could go to real-time if we wanted. But it's not relevant in my use case. And also, it feeds into the second learning objective or the second constraint. As I'm trying to learn here, I want to stay within the free tiers within Azure and also minimize my ingress and egress costs. So ingress and egress are fancy words for the amount of data I send into the cloud and take out of the cloud. So depending on how I set the frequency with which we upload, I impact both the number of messages that I consume within the free tier and the amount of data I consume. I'll show you exactly how to manage all of this later. And then finally, the sensors are distributed. As I mentioned, one is in the fridge and another in the bathroom and one in outdoor. And the distance from the sensor to the gateway impacts the signal strength and hence the frequency with which I actually get data to the gateway and hence into the cloud. And there are some settings we can tweak to make sure that that improves. So let's just remind ourselves of the architecture. I think I've repeated already that we have a number of S1 sensors. On those, we can change the transmission interval, so the frequency with which it sends data to the gateway, and we can impact the transmission power or signal strength. On the G1 gateway, we can change the upload interval. This impacts directly the number of messages that we use within our tier. We can do data filtering on the G1 device. That impacts, to a very small extent, to be honest, the data ingress into Azure, but also we can simplify a bunch of stuff and minimize our data consumption by thinking smartly about what we actually need to send. So I'll show you that. And finally, there's a quality of service setting. For my use case, I can leave it at the default of 0, but I'll show you the impact nonetheless. In Azure, at the IoT Hub, we can change, of course, the pricing scaling tier. I wish to stay within the free tier, so I'm constrained by about 8,000 messages. And then finally, to make all of this happen and useful, we need to go and start tweaking within our Stream Analytics job. So let's start there. All right, first let's log into our Azure portal, click on our Stream Analytics job, and we observe that it is running. This means that we're processing data off of the sensors, running it through IoT Hub into Stream Analytics and pushing it over to PowerBI. So let's just check in on PowerBI to see that everything is good. Yes, I started this job about 20 minutes ago, so we have 20 minutes worth of data. This is the humidity by MAC address or for every single room, and this is the temperature by MAC or room. And I can just tell you that this one here, being almost 9 degrees centigrade, is my fridge. It's a bit warmer than I would like because I made about 5 liters worth of lemonade earlier in the day, and that's currently being cooled. Outdoor, which I believe is this one, it's about 18 degrees centigrade, and inside the house I have between 26 and 21. So let's go back into our Stream Analytics job and first stop the job. Yes. It's only when the Stream Analytics job has been fully stopped then you can edit the query. And what I want to do is add a few more variables into our query. So I want to add the min of our SSI. So within the 30-second window, I want to collect what is the lowest or weakest signal strength for that particular MAC address. Say strength, comma. Remember the commas at the end when you add more variables, otherwise you will get an error. And then I want to have count of our SSI. So this just counts the amount of rows or readings that came off that particular sensor during those 30 seconds that we're grouping them into, which is the 30 seconds of the tumbling window. As ping count. All right, we'll save and we'll test. And this looks nice and pretty. We have our 5 sensors. We have the average temperatures, average humidity, the weakest signal strength that came off of it during those 30 seconds, and the number of pings that we're getting off of it. Excellent. Let's go back to the overview and click Start. And now it'll take a few minutes to start up. While we do that, while it starts up, I'll go over to PowerBI. Every time we change the query in Stream Analytics, it gives us a bit of trouble. The best thing to do is go into your data sets. This is our data set, and just delete it. That way a brand new data set is pushed through in a matter of minutes. The bad thing is when you do that, your dashboard is actually destroyed. So in a few seconds we should see all of these. Yeah, there it goes. They're deleted together with the data sets. But this was fairly simple to create, so I'll recreate it as soon as the data set back through from my Stream Analytics job in Azure. So I'll pause the video while we wait. Okay, so now a brand new data set is being pushed through by the Stream Analytics job. You can see the little arrows here suggesting it's new. If we click on the 3 dots and go to API info, we'll see here that we have the signal strength, the variable I just created, and it's indicated that it's a number, and we have ping count, also indicating that it's a number. Fantastic. Let's create a new dashboard. I'll pause the video so you don't have to watch me do that. Okay, so I've recreated the dashboard we had before. We have our temperature by MAC address here. We have the humidity by MAC address over time in the line chart over on the right. And in the bottom, I've added 2 new charts. The chart on the left shows the minimum signal strength over the last 30 seconds for the different MAC addresses. Now, higher is better. So the fact that we have it at -79 is really bad, because beyond -80, the signal is not picked up and processed. So this particular sensor is too far, potentially too far away from getting the signal through to the gateway. If you then look on the right, the number of readings per second. On purpose, I've set them not to coincide perfectly with one another, but also we'll notice that the one with the MAC address starting with E or finishing on E9, the one that's really weak, actually drops off. It goes to 1 or 0, it drops off our chart. So it is just out of range for getting its signal through to the gateway. And of course, having a bunch of signals coming in within 30 seconds, this is above 10 seconds, 10 signals per 30 seconds, which means every 3 seconds, might not be helpful to my use case. So let's move over to the devices themselves and see what we can do there. Now we're on my iPhone. From Minew, you can download an app called Beacon Set Plus. And this particular app allows you to identify and configure each of your individual S1 sensors. So when you open it and have Bluetooth activated, it will scan the environment and identify your sensors. As mentioned, I have 5 S1 sensors, and the one that's giving us a bit of a hard time is the one that has a MAC address that ends with E9. So that's this particular one. If I double click on that, then I'll open it and it'll ask for the password. The default password is Minew123. Click OK. Then it reads a bunch of slots or plates as they're called. I'll move across the top here to the slot 6, which has to do with the humidity and temperature sensor. Here I have a number of variables. The first one we want to fiddle with is the advertising interval. This impacts how frequently in milliseconds or how many milliseconds you want to pass between each time it sends off a signal. For my use case, every 5 seconds is perfectly fine. Then you have RSI at 0 meters. This is a way for you to calibrate the strength of the signal and calculate the distance from the sensor to the gateway. I don't need to touch that, but I do need to change the radio transmission power. For the purposes of this tutorial, I'd lowered it prior to starting to ensure that I got the results I wanted. The default is 0 millidecibel, but since this particular sensor was weak, I'll actually increase it to 4 millidecibel. And I'll hit save, and that's that. You can do the same for all of your sensors, increase the frequency or decrease the frequency with which it sends the data to the gateway, and also increase the transmission power. I'll now go through all of them and set them all to send every 5 seconds, and then we'll see each other back in PowerBI in a few seconds. All right, now we're back in PowerBI after having adjusted the settings on each of the individual sensors, and if we've adjusted the advertising interval, we've set that to 5 seconds for all the sensors, and I've increased the transmission power for 2 of the sensors, particularly this one, which was very close to 80 earlier in this video, and for this one, which was also much closer to minus 80 earlier in this video. So now they're consistently smaller than minus 80 or higher than minus 80, closer to 0, which indicates that it has higher transmission power. I've also, for this particular sensor, taken the frequency with which it sends a signal or a reading and set it from every 500 milliseconds, twice per second, to every 5 seconds. And that's why you see this dramatic drop, right? So these are the 2 ways that we can adjust the settings on the S1 sensor that translate through to quality of the readings. Now let's go over to the G1 gateway and see what we can do there. So we found our G1 gateway. Let's log in. It'll remind me that I still need to give it a password. I will do at some point. Once logged in, we move across to the service pane. And the first thing we want to do is change the upload interval from 1 second to maybe 30 seconds. But first, let's take a shot at before and after. So let's move to Azure and have a quick look within our IoT hub. If we go to Azure and find our IoT hub, then in the overview pane, we'll see here the number of messages being consumed. There's a few metrics. Let's take this one. I'll just adjust the settings, last 30 minutes, and hit apply. If you move this bar, you'll see that for every single minute that passes, I use about 120 to messages. The way the logic works is that every time I send a message from the gateway to the cloud, it'll send a message back confirming receipt. So every second, if I send a message from the gateway, I actually consume 2 messages. Another way we can look at that is device to cloud messages. They're roughly stable at, somewhere between 35 and 45 messages per second. This should be much more stable than that, but it will fix this. So let's go back into our gateway and we'll change this from 1 second to 30 seconds and hit apply. Done. In no time, we should here see this level out at 2 messages per minute. So we are sending every 30 seconds. So the line we currently have up here will drop to somewhere down here. We'll just give it a second. While we do that, let's go back into the gateway and I'll explain something else. Here you have a setting for quality of service. If you leave it at 0, it'll only attempt it once and just get an acknowledged receipt. It will not send things multiple times. If one of the sub-messages got lost, it will not try those again. To ensure that, you need to go to quality of service 1 or 2. And there's some great YouTube videos that differentiate and explain the technicalities of this. One thing that is very clear is if you go to quality of service 1, the number of consumed messages doubles. So if you want to stay within the constraints of the free tier and you don't want to consume too many messages and generally have good internet connection, just hit refresh and there we go. It's now dropped the number of messages to 5 per minute. We'll see it drop to 2 per minute and next time we refresh. Some other settings within the gateway that are useful. If you go down here to filter duplicate data, we've set it to no, but if we set it to yes, we have a number of options. If you select filter by MAC, then for every 30 seconds, which is now the interval that we have set it to upload data with, it'll only send 1 reading per MAC address. So it'll do all the filtering in the device and just send the last one. If you do by MAC plus type, each MAC address could, in theory, send different types of messages. It also sends an iBeacon message, which is used in advertising. But I don't use that in my use case, so it's no. So it doesn't really make any difference for me whether I filter out by MAC and type. The last option is filter by MAC plus raw. This means that it actually, in the gateway, compares the variables and only sends out 1 unique message for each sensor. And to illustrate that, let's move across to Visual Studio Code, where I'm monitoring my data. I'll just see if I can take a snippet of some of this. So here's a good example. All right. So all of these messages were sent together by the gateway. You'll notice here that the temperature is now 7.97. This is my fridge again. And this is set at 451 and 2900ths. We take the last one here. And at 26.4, and this message, which is identical, and the same temperature, is sent half of a second later. Now, I'd set that particular sensor to do every 500 milliseconds, so this is okay as per the settings, but it's really a waste for my use case. So what I can do here on this setting is if I filter it by type and raw, then it'll stop sending repeated data and only take unique messages every 30 seconds. And this is quite helpful in my use case. So I'll select that and hit apply. What we should then expect to see is nothing here. The message count will be the same. It'll just be the number of messages within the message that has changed. So the way the last change will manifest itself will be here. We should see all of these drop to maybe 1 to 3 messages, depending on whether they're unique, per interval of 30 seconds as we look at PowerBI. The effect of that is that we will save or economize on the number of messages we consume within the free tier. Again, if you're just seeking to learn, it may have no practical implications for you, that you actually have lower granularity in the data. We should be able to see, maybe in 15 minutes, that this line here, the slope decreases as we decrease the frequency with which we upload data. So that'll become apparent in a few minutes. And with that, we've actually concluded the first section of this third tutorial. We've covered some of the topics around the pricing scaling tier. We've covered how we can change the transmission interval on the sensors, how we can change the transmission power on the sensors to make sure that we get data coming all the way through to the cloud. We've gone through and looked at how we can change the upload interval on the G1 gateway and how that impacts the consumption of messages within our free tier. We talked about data filtering and how we can take out redundant data. And we've talked briefly about the quality of service, how that impacts the number of messages that we consume within the free tier. Next, we'll talk about how you add reference data to your stream analytics queries. Let me first elaborate on why it's helpful. As your streaming data comes in, and you put it into a tabular format, it'll look something like this, right? You have your temperature, your humidity, your signal strength, your ping count, and your MAC address. As this becomes one long stream, it's very difficult to figure out which sensor is where. And you might want to add some static limits to it. So adding reference data, or joining reference data as it's also referred to, is about linking it up with a second table where you could have more static variables. In this case, the location or the name of that particular sensor, you could give it a minimum value and maximum value, and you could give it a sort of a type. You can continue creating as many as you want of these. In this case, for instance, in my fridge, the minimum value should be 3 degrees, maximum value should be 5 degrees, and I've defined it as a type of appliance, whereas the bathroom would be a shower, and the bedroom and living room would be standard measures. So that's what you could use a reference data set for, and join it up with your streaming data to make it more useful. So let me show you how you actually do that. To add a reference data set to our stream analytics job, we actually need to go through 9 different steps. First, we need to create the reference data table. Then I recommend that we change it to a JSON format. Then we need to go and stop the stream analytics job in Azure. Then we need to add a folder in our blob storage container in Azure. We need to upload the JSON file to that folder. Then we need to create and add a new input source into our stream analytics job in Azure. Then we need to update the query so that we can make the join between the streaming analytics dataset and the reference dataset. Then we need to restart the stream analytics job again, and then go over to Power BI and do the necessary tweaks so we can use the new reference data in our visuals. So please tag along as we go through all of these 9 steps. Creating a reference dataset is nothing more than a CSV file, or basically an Excel file saved as a CSV. Here I've pre-populated it with the MAC address, the location, the floor it's on, the orientation, whether it's interior, north, south, min and max temperatures, min and max humidity levels. That's it. That's what a reference table is. You can add as many fields and columns as you'd want. Now, being in Europe, using CSV files is a bit tricky in this context. We use commas to separate integers from decimals, and that creates a bit of a problem when you make comma-separated values. I can, of course, change the delimiter to something else, but the easiest thing to do is just take your CSV file and convert it to a JSON file. There are a number of free online websites that can do that. I use this one. You dump the file, click convert, download, and you're good to go. So let's head over to Azure and see what we do there. Once back in Azure, the first thing we want to do is go and stop our Stream Analytics job. Click the Stream Analytics job, hit stop, click yes. We'll go back to home. Next, we'll go to our storage account. Click on containers, and this is one of the containers that we have. We'll click upload, we'll select the file. This is our JSON file that we created for. We'll just rename it and call it AC555 ref data. Open, we'll click advanced, we'll put it into an input folder, and we'll hit upload. Should be uploaded now. Let's just check. Hit on input, AC55 ref data JSON, and we'll click edit so we can. It looks good. Okay. Then let's go back to our Stream Analytics job and create an input. Click add reference input, blob storage. We'll call it the input alias will be AC55 ref input. We'll select our free trial subscription. We'll create a storage account. We'll use the existing container. The path will be input /AC55 ref data.json, and it's a JSON format and UTF-8 format, and then we'll click save. It'll do some tests. Let's see here. Yeah, adding input. We'll just wait for that to complete. Okay, so the test was successful, and we'll go to query. Remember, we stopped the analytics jobs earlier, so we can go straight into the query window and start editing. We'll take the last two queries that we've created, which are the ones that push data into blob storage and to PowerBI, and we'll just delete those. Then we'll insert a new query that I've prepared. Let me talk you through what it does. It selects all the data objects or all the columns from something called stream input, and it selects all the columns from something called reference input. Now, the way we're doing the join requires that we give our inputs a new name. So we have from the reader query, and then the space here gives it a new name, which is stream input. So this stream input is actually just an alias for the reader query, and the reader query is what we have up here. Then we do a left outer join on AC55 ref input. That's the new input that we just created a second ago. With this space here, we give it another alias, which is reference input. And then we say we left outer join on stream input. So this alias .mac is equal to reference input.mac. So the MAC addresses will be what joins it up. And I see we have a small typo here, so it's the PowerBI. Now we can see we have the little icon here that suggests it's being used, but we don't have anything for blob storage. We'll take the whole thing, we'll copy and paste it, and then we'll replace the into, instead of PowerBI, we'll just change this to blob, and then we create a copy of that into blob storage, and we're good to go. Save. Now, static data or reference data cannot be used in preview mode, so we cannot do a test here to actually see if it works, unfortunately. So we'll hope it works and go over to our overview and click start. It'll take a few minutes for it to start up, and we'll resume from then. Okay, so now our Stream Analytics job has started successfully. Let's head over to our storage account and see if it works. We'll go to our output, and we should now have a file from right now. Yep, here we go. 8:03 p.m. That's just around now. Open, edit, and there we go. Here we have the original MAC addresses, the timestamp, the average temperatures, the humidity, the signal strength, the ping count, and we have the location, the floor, etc. This is fantastic. So we have the bathroom, bedroom, floor 1, 0, the orientation, the type of room it is, whether min and max. So it's actually working. Fantastic. Now let's see what's happening over at Power BI. Typically, it takes a few minutes before the data comes through, and here it came. Excellent. And if we click on API info, we will now see the data architecture. So we have our MAC address, which is a string, a date field, then we have numbers, the location is a string, the floor is a number, the orientation is a string, the type is a string, and the rest are numbers. Fantastic. Now, as I deleted the data set here to have a new one pushed in from Azure, the dashboard that I created earlier no longer exists. So I'll pause for a second while I recreate it. Okay, so now I've recreated the 4 visuals that we had earlier. Of course, an hour or so has passed since I last looked at this. So some of the data, because the data sets have changed, we don't have a full hour going back in time. Now, the problem we had prior to adding the reference data was that we had these MAC addresses that nobody knew what was. And it's quite useless, honestly. So what we do now is we click on the 3 dots and more options. We click edit. Instead of having the axis being the MAC address, I change that to location and hit apply. Now you'll see that the MAC address has been translated into the bathroom, bedroom, living room, fridge, and window. Do the same here. Edit, MAC, location, apply. Location, apply. And I'll do it on the last one just to make sure that it works. Clearly it didn't. Ah, there it came. All right, so now it works. Just a few seconds delay. So now I've translated all the MAC addresses using reference data into something that is more useful. And with that, we have concluded the second segment of tutorial 3. In this third segment, I want to create some more interesting visualizations in Power BI. So let's head over to Power BI and get started. This is where we left off. Well, let's go to my workspace, click New, click Report, select the published dataset, take the Power BI dataset. So let's create an interesting report. The first thing I'd like to do is create a slicer. So we'll just click here, drag it across, and I want to be able to filter on which room it is that we're looking at. Remember, this was only feasible because we added reference data. So we'll click cross report, and here we will make sure that it says requires single selection. That ensures that we won't have 2 or 3 different rooms being aggregated at the same time. Next, we'll add a gauge. Click, and to this gauge, select it here, the main value I want to show is the temperature. So I'll add that as the value here. The minimum I want is the temperature lower limit that we set via the reference data. The maximum should be the temperature upper limit, which we set. Then I want to show only the latest value and not aggregate. And to do that, we need to take the timestamp, add that here to the data field. Then we, under filter type, we take top n, we'll take the top 1 observation, and then it says add data field here. So I need to take the timestamp again and put it on, and then I need to apply latest, and then hit apply filter. Before I hit apply filter, do observe that how it's summed all of the values in the data set for temperature. Makes no sense. The aggregate of temperature measurements over time. Now we hit apply, and now it comes down to 92. That's because we still haven't applied any of these. So now if I take fridge and hit fridge, I have these 6.8 degrees in my fridge. And I will go and hit bathroom, 22 degrees in the bathroom. Let's make another gauge. And this time I'll take humidity as the value. I'll take the humidity lower limit as the minimum value, humidity upper limit as the maximum value. I again want to be able to have just the latest measurement, so I'll take timestamp and add that this time over at data field here. Then I'll select, instead of basic filtering, I'll take top N, I'll take top 1, then I need to filter it by a value. I then take timestamp again. Now instead of taking the earliest, I now take the latest and I hit apply. You should see how we now have only logical numbers here that make more or less sense for humidity. So this is the average humidity in the bathroom right now, where I've set a lower limit of 20% and an upper limit of 45%. Let's continue. Let's make a line chart. Alrighty, move this here. Alright, I'll make a line chart for temperature. So the value I want to show is the average temperature. I want to show that over time, so that'll be my axes. And just to make sure that we actually get the temperature for the right room or the selected room, I'll click location and drag that to legend. Let's create one more. Take that for humidity. Of course, this can be a lot prettier if you spend a bit more time, but this is a tutorial. I'm not going to give you lessons in how to make it super pretty. We take humidity for value, we take timestamp for axis, we take location for legend, and there you go. Now let's see how it works for the fridge. Yep, it then takes the fridge data. The fridge has been moving between 6.5 and 7 degrees. The humidity has gone up and down. This is where the cycle of the fridge starts. I've accidentally set the lower limit higher to what is actually normal in our reference data, so you can go back and fix that. And there you have it, a much more interesting. We do one more thing though. Let's take and make a card. And for the card, I just want to observe the number of pings that we have. So I'll take the number of pings, and then we will apply the timestamp again. We'll apply that here. We'll go to top N equal to 1, and we'll take the timestamp again, drop that here, take the latest, hit apply, and then we have 1. So I'm getting through every second only one measurement from my sensors that comes through the gateway. Remember, the sensors are set, as I showed earlier in this tutorial, to send a signal every 5 seconds. So the signal every 5 seconds goes to the gateway. There it filters and only sends unique signals to the cloud. So what we're measuring here is the number of unique signals sent from my sensors via the gateway to IoT Hub and through Stream Analytics, and then it aggregates and counts in chunks of 30 seconds or tumbling windows of 30 seconds. So for most of these, I should only get one measurement or one ping count per 30 seconds, and that would be unique values. In the fridge, in the bedroom, I'm getting 2 unique, but in the living room, I've only gotten 1, and by the window, I've only gotten 1. One of the interesting things, if we just to make one more chart, is to take this over time and see how it works. I expect we get values between 1 and 2 the whole time. So let's take ping count, put that as our value. We take the timestamp, put that as our axis. We take the location and make that our legend. Yes, and lo and behold, we get between 1 and 2 for every 30-second interval, and the latest one is just 1. So if I change that to the fridge, get 1, 2, in some cases I get 3, it means that the fridge is either cooling or heating very quickly. If I align this chart here, maybe it starts to make more sense. Then we'll take fridge. No, it doesn't make any sense. These spikes in number of measurements don't really align with these up here, but the time, oh well. So that's a much more interesting visual representation of the data set we get off just looking at temperature in my fridge. Hope you enjoyed this third segment. We'll now go back and look at the fourth. So in this last section, let's talk about how we can monitor the sensor data quality. The problem that we have is that we have adjusted on the S1 sensor so that it only sends out a signal every 5 seconds. That of course increases the probability that a signal might not make it through to the gateway. We have of course increased the transmission power, which should overcome some of that risk in case the sensor was too far away from the gateway. But still the risk exists. At the gateway, we've asked it to filter out all the duplicate readings so that we only have unique readings from each sensor where the temperature and or humidity readings are different from anything else that's been sent out from the sensors to the gateway in the last 30 seconds. And then we've asked it to only upload to Azure every 30 seconds. And in Azure, we then aggregate, average and count the number of readings by each MAC address or each sensor every 30 seconds. So in theory, all of this should work okay, but there is of course the risk that during a 30-second interval, a sensor set of readings does not make it to the gateway and hence doesn't make it through to Stream Analytics and into PowerBI. So the question at the end of all of this is, how many of my sensors are online? So now I'd like to just show you a way to make a mechanism for monitoring that. So let's head over to Azure and head into our Stream Analytics job and first stop the job. That typically takes a few seconds, so I'll pause the video while we wait. The analytics job has now been stopped, so let's go and create a new output. I want to create a new output into PowerBI. So we'll click Add, select PowerBI, we authorize, and now that is done. We'll create an output alias, we'll call it PowerBI monitor, we'll call it alive, basically short for how many of my sensors are alive or online. We'll test the output. Okay, then let's go into our query. And within the width, we'll copy paste in. So we'll create a new feeder query. I'll call this one alive, and it will select, it'll set a new timestamp. It'll then count the distinct MAC addresses as sensors online. It'll count the number of pings, and this one it won't recognize because we called this ping count. So we'll just change that to ping count, and we'll call that as sum of pings. We'll read that from the reader query and group by tumbling window of 30 seconds. So we have that. Then we will go and create a new output query. So we'll add that here to the end, and we'll select everything, and we'll put that into Power BI Monitor. from our query that we called alive. And we can see that now this is in use, and the squiggly line that were underneath this before have now been gone. That was to indicate that there might have been an error. But now we have basically two feeder queries. One is called a reader query that just takes the raw data. The second query, which is also a feeder query, takes off the reader query, compresses it even more, and then we have three output queries. The first one puts it into PowerBI, the second one puts it into blob storage, and the third one takes our live query and puts that into PowerBI as well. So that should all work. We'll go into overview, click start for a stream analytics job, wait for 2 or 3 minutes, and I will pause the video while we wait. Our stream analytics is now running, so let's head over to Power BI and see what comes through. So this is the dashboard that we made just a minute ago. We'll go to my workspace, we'll take data sets, and in a few seconds, hopefully, a new data set called live should come through. I'll wait until it does. And here it came. Let's click API. We have a timestamp. We have the sensors online. We have some. This just indicates that they're all numbers. This looks the way I had expected it. So let's go to our dashboard and add a new tile. I'd actually like to create a line chart from alive so that we can see over time the number of sensors that are online. So we'll have sensors online and we'll monitor that for 60 minutes. Sensors online over time. This is count out of 5. Apply. Now we're just waiting for data to come through. And now we have data coming through. The line plateaus at 5, which means that all 5 of my sensors have within any 30-second window send at least one signal through. And that's all that I ask for my use case, that all of my sensors are online. And as we can see here, all of them seem to send between 1 and 2 signals, some 3 in very unique circumstances. That's mainly the fridge. So that's that. We now have a new tile or a new way of monitoring how many of my sensors are online. And with that, we've actually concluded this tutorial on how we can tweak the setup and get the best of our monitoring and IoT at home with Minew and Azure IoT. Thank you everyone for attending. If you enjoyed this, please subscribe, give it a thumbs up or a like, leave a comment. Thank you very much. Have a great day.